Hello friends, this is Chandrakant Ghosh. Today I'll tell you about control chart. Control chart is a statistical tool used to distinguish between process variation resulting from common causes and special causes. It is also used to see the stability of the process. Control chart is also known as Seward chart because it was introduced by Dr. Walter Seward. Therefore, it is also known as Seward chart. Now, since we have talked about common cause variation and special cause variation, so let me explain you about the common cause variation and special cause variation. Common cause variation is the natural variation in the process, or you can say it is the part of the process. It is also known as natural variation or noise or random causes. For example, humidity and temperature are the common causes. And special cause of variation on other hand is the unexpected variation in the process because of a specific cause, and this specific cause is known as special cause of variation. For example, uh, variation can be in material properties, improper test procedure, or wrong measurement. These are the example of the special cause variation. Now let's see what is control chart. Control chart is a very important tool of Lean Six Sigma. It is a graph used to study how a process changes over time. Control chart has a central line which is actually the process mean. It has an upper line for the upper control limit and a lower line for the lower control limit. Control limits are based on process variation or the process data. The control limits are plus minus 3 standard deviation from the process mean or the central line. This is the control chart which you can see that the center line is the process mean, upper line is the upper control limit, and the lower line is the lower control limit. X-axis shows the data which you have collected over a period of time, and the Y-axis shows the scale of measurement. Now, types of control charts. Control chart depends on the data type. There are two types of data. One is continuous or variable type, and another is attribute or discrete type data. That means the control chart are of two types. First one is control chart for variable data, and another is control chart for attribute data. Now, if your data is continuous type or variable type, then you have three types of control chart. That is IMR chart, X bar R chart, and X bar and S chart. And if you have data which is attribute type or discrete type, then you have four types of control chart, which are P chart, NP chart, U chart, and C chart. Now we'll see how to select the control chart. When you have continuous data, then the selection of control chart will be based on the subgroup size taken from the process. That means if you have a continuous data and the sample selected is individual measurement, then the subgroup size is 1, and then you have to select the IMR chart, that is individual moving range chart. And if you have continuous data and the sample selected is subgroups averages with subgroup size from 2 to 8, then you have to select the X bar and R chart, that is X bar and range chart. And if you have continuous data and the sample selected is subgroups averages with subgroup size more than 8, then you have to select the X bar and S chart, that is X bar and standard deviation chart. Many people uses X bar and R chart when they have subgroup size from 2 to 10, and they use X bar and S chart when they have subgroup size more than 10. Now let me explain you the concept of the subgroup size. Suppose we have a team of 5 person and you are collecting one sample from each person every day, then your subgroup size is 1. When you are collecting 2 to 8 samples from each person every day, then your subgroup size lies between 2 to 8. When you are collecting samples more than 8 from each person every day, then your subgroup size is more than 8. So accordingly you have to choose your control chart. Now come to the attribute data. Suppose your data is attribute data or discrete data, then the selection of control chart will depend on the lot size or defect or defective. So let me tell you about defect. A defect is a fault or imperfection in a product or service specification which is not meeting customers' requirement is a defect. And a defective may have more than one defect. Now a lot size may be constant or variable. Let me tell you about the constant lot size. So if you are producing 100 product every day and you are collecting 10 product as a sample to check the quality of the lot size, then your lot size is constant lot size. And when you are producing 100 product one day and another day 150 product and another day 200 product, and you are collecting 10% of your produce every day as a sample to check the quality of the lot size, then your lot size is variable lot size. When you have attribute data or discrete data, then how to select the control chart. Suppose you have attribute data or discrete data, and if you are being monitored defect and your lot size is constant, then you have to select C chart. If you are being monitored defectives and your lot size is constant, then you have to select the NP chart. If you are being monitored defect and your lot size is variable, then you have to select the U chart. And if you are being monitored defectives and your lot size is variable, then you have to select the P chart. So now I hope you have understood when to select which chart when you have attribute data. So this was all about the control chart, and I hope you have understood about the control chart and how to select the control chart when you have attribute data or continuous data. I hope you like this video. If you like this video, then don't forget to subscribe it by click on the bell icon. Please share this video to your friends and colleagues to improve and refresh their knowledge. We will see you in my another video with the same topic, that is control chart. Have a good day.